Good morning all. How are you all? Doing good? Very good. So today, let us first revise what we learned in our previous class. Are you ready to revise it? Yes. Then, what is an atom? What is an atom? Atom is the smallest particle, isn't it? Atom is the smallest particle of matter. Very good. Then, can you say the symbol of hydrogen? What is the symbol of hydrogen? Yes, symbol of hydrogen is H. Then what about helium? That is He. Hydrogen symbol is H and that of helium is He. Very good. Then what is a molecule? What is a molecule? Yes, the simplest independent particle of a matter, isn't it? Simplest independent particle of a matter is molecule. Then what is the molecule of hydrogen? How it is represented? Molecule of hydrogen. Is it H? No. Then that is H2. Very good. That is H2. What about helium? That is He itself, isn't it? H2 is the molecule of hydrogen and He is the molecule of helium. Very good. Then can you say HCl? HCl. What is this? Hydrochloric acid, isn't it? HCl. HCl is a molecule. Is it a molecule? HCl is a molecule or not? Confused? Then let us find it out in today's portion. And our topic is compounds. So first, I am going to write some molecules here. And you want to find out their corresponding atoms, isn't it? Are you clear? I am going to write some molecules here and you want to find out its corresponding atoms. You want to find out its corresponding atoms. So first, my molecule is hydrogen chloride. Hydrogen chloride. Hydrogen chloride. What is its symbol? Yes, HCl, isn't it? HCl. Which are the corresponding atoms? Which are the corresponding atoms? Hydrogen. Then what? Hydrogen and very good, chlorine. Hydrogen and chlorine. Now next one is sodium chloride. Sodium chloride. What is its symbol? NaCl, isn't it? NaCl. And what is atoms of sodium chloride? Sodium. And then what? Then what? Very good. Chlorine. Sodium and chlorine gives sodium chloride, isn't it? Now next one is carbon dioxide. Carbon dioxide. That is CO2. Carbon dioxide, CO2. What is the atoms in carbon dioxide? Yes, carbon. And then what? Carbon and oxide. Oxide means? Yes, oxygen. Carbon and oxygen is present in carbon dioxide. Next one is our water. 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 What we have in water? What is the symbol of water? H2O, isn't it? H2O. Then what are the atoms of water? H2O. What are the atoms of water? Just look into the symbols. What are the atoms? Yes, hydrogen. Hydrogen. Then what? H2O. Then what? Hydrogen and oxygen. Very good. Hydrogen and oxygen. So, we have split out the molecules into their corresponding atoms. And we have seen that atoms combines to form molecules, isn't it? Atoms combines to form molecule. So you have seen that here hydrogen and chlorine combine to form hydrogen chloride, and in all these cases at least two atoms are combined to form a new molecule, isn't it? It can be 3, 4 or 5 number of atoms to combine to form a molecule. It can be the number can be greater than 2 or equal to 2 to form a molecule. Now my question is that, is the atoms same in all these cases? Is the atom same? Is the atom same? No, isn't it? Here we have hydrogen and chlorine, not hydrogen, isn't it? Both are not hydrogen. It is hydrogen. Hydrogen is different element and chlorine is different element. Similarly, here we have sodium and chlorine. Both they are different. So we have seen that these atoms are different, and these different types of atoms combine to form a type of molecule. And this type of molecules which combine by different types of atoms, just formed by combining different types of atoms, are known as, and it is called compounds. What is it? Compounds. So when different types of atoms combine to form a molecule, and that type of molecule is known as what? Compounds. Compounds. So you are clear with the topic compounds, isn't it? Now watch a video and watch it carefully so that you may be able to answer my questions. Okay, watch it carefully.
Carbon is a fairly unreactive non-metal, and it's black in color. Here we have some charcoal, which is carbon, and we're going to take some in a deflagrating spoon, and we're going to plunge it, once it's started burning, into a gas jar. So we heat it over the flame of a Bunsen burner. It won't really ignite very spectacularly because it isn't very reactive, but it glows with a reddish color. And we'll plunge it into the oxygen in the gas jar, and carbon reacts with oxygen to form carbon dioxide gas.
Now let us watch the thermal decomposition of calcium carbonate, and we can see that while heating the calcium carbonate in the test tube, we can see some bubbles are formed in the collecting test tube, and the bubbles formed is carbon dioxide gas, which has the chemical formula CO2.
Have you watched the video? Yes. Very good. Then let me ask you some questions. My first question is that, what was the gas formed when carbon burned in oxygen? What was the gas formed when carbon burned in oxygen? You have seen the carbon burning in oxygen. It was a reaction, isn't it? Then what was the gas formed then? Very good. That was carbon dioxide. Carbon dioxide. Then which was your second reaction? Yeah, decaying or decomposition of calcium carbonate, isn't it? Decomposition of calcium carbonate. Then what was the gas formed in that case? Which gas was formed in that case? Very good. Again it was carbon dioxide. Again it was carbon dioxide. So first you see that when carbon burned in oxygen, which was the gas formed? Which was the gas formed? Carbon dioxide, isn't it? CO2. Then next case, decomposition of calcium carbonate. Calcium carbonate. And what was the gas formed again? Carbon dioxide, CO2. So in the first case, how many carbon are there in the carbon dioxide? In the first case, how many carbon are there in the carbon dioxide? 1, isn't it? In the second case, how many carbon are there in the carbon dioxide? 1. How many oxygen are there in the first case? 2. How many oxygen are here? Yes, 2. Is there any difference in the number of carbon and oxygen in both cases? We have seen two processes of forming carbon dioxide. Is there any difference in the number of carbon and oxygen in both cases? Is there any difference? No, isn't it? There is no difference. The number of carbon and oxygen in both cases were same, isn't it? Then can you write the ratio of carbon to oxygen in carbon dioxide? What is the ratio? Yes, that is 1:2. So you have seen that the different process was evolved to produce a same compound, isn't it? Carbon dioxide is a compound, and whatever be the process of production of these compounds, there will be always a ratio like 1:2 here. There will be always a ratio maintained in the formation of a compound. So our second point is that these compounds possess a fixed ratios. A fixed ratio. These compounds possess a fixed ratio. Are you clear with that? So now your task is that I'm going to give you some questions. You want to note down, and the questions are on the screen. You want to note it down and record these answers, your findings in the science diary, and send it to me. And that's all for today. Have a nice day. Thank you.